Hello, geometry students. Here we are with our homework 3.3, which is proving lines parallel. Let's see if we can look a little in our camera a little bit. Oh well, it's all right. We'll get through this. Proving lines parallel. So we've been working on transversals and the different angle relationships that those form, such as alternate interior angles, corresponding angles, same side exterior angles, etc., etc. And so 3.3 basically takes those same concepts and then moves in a slightly different direction. And so here we go. We're going to start with the definitions, and then we just have, actually, there's one definition and then a couple questions. So let's go ahead and get started. One definition, converse theorem. And then this in itself basically summarizes what the main idea of this lesson is. And that is a converse theorem, which if you remember what converse means, it takes the uh, hypothesis and the conclusion and then swaps them, swaps the P and the Q. And so this says, proves lines parallel if their proper angles are congruent or supplementary. And if you remember from 3.2, what we said is we started with the other way. We said if the lines are parallel, then we know things like same side interior angles are supplementary, or corresponding angles are congruent, or alternate exterior angles are congruent. And we knew those things, those angle relationships, because we knew ahead of time that the lines were parallel. Well, the converse theorem just shows us that it can work in the opposite, in that you can prove the lines parallel if you already know the angle relationships. And that's what we'll summarize that in a few more ways moving forward. But what you'll see here, I'll just use the little illustration, is that if, for example, looking at this picture, you're given a transversal and you're given those angles 1 through 8, and then they were to tell you that angle 3 plus angle 6 equals 180. So if they told you that and you said, hey, wait a minute, those are same side, we're looking at angles 3 and 6, those are same side interior angles, which uh, are supplementary. And so if they tell you that first, then what this allows us to infer is that these two lines, let's go ahead and call them line A and line B, in that if I know first that the two lines are supplementary, the two angles are supplementary, and they're two angles that are supposed to be supplementary, then I can infer that um, line A is parallel to line B, and I can then add these two marks. So it's nothing that you don't already know, but they're just showing you that you can follow it logically in either direction. One, if you know the lines are parallel, then you can know that the corresponding angles must be congruent, or the alternate interior angles must be congruent, or any of those 5 angle relationships that we discussed. But now they're showing you, if say you don't know the lines are parallel, but you do know even just one of those angle relationships. I just picked one. I could have also done something like angle 1 is congruent to angle 5. Well, that means they're corresponding angles. That would also prove, as I've written here, that A is parallel to B. And so that's what the converse theorem is. It's using the angle relationships to prove that lines are parallel. Okay, let's scroll down and take a look at our questions to try to flesh this out. So question number 1 and 2 look at what I was just trying to say. They say number 1 says parallel lines allow you to know the. So in other words, if you know the lines are parallel, oops, let me do it in this color. If I know my two lines are parallel and I have a transversal, and again, they tell me that they're parallel, then I can infer from that the angle relationships. And so that's what we're looking at here, is that we can infer angle relationships, namely which angles are congruent and which angles are supplementary. If I know ahead of time that the lines are parallel. That's what we did in 3.2. 3.3 is this question number 2. Number 2 says, knowing the angle measurements allow you to prove what? Well, the opposite of this. If I know the angle relationships, then that allows me to prove that the lines are parallel. So this is where we get the word converse, because a converse is just the reversing of the P and the Q, or the hypothesis and the conclusion. And so that's what we have here. If we know the lines are parallel, then I can know the different angle relationships. Or if I know the angle relationship exists, then that means, therefore, the lines are parallel. So you get, that's what 3.3 is all about. Nothing new, but looking at it from the other direction, Q to P. All right. So then question number 3 asks, when will you use converse theorems? When will you use converse theorems? Well, and so the short answer to that is whenever you know the angles and need to prove lines parallel. Okay, so that's what we just set up here. If you know that the angles are, same side interior are supplementary, or you know the corresponding are congruent, then you can use a converse theorem to prove you need to prove the lines parallel. So for example, let me go ahead and sketch something here as part of this answer. So say I have a transversal, and I'm going to call these two lines C and D. And if they tell me that this angle and this angle are congruent by those red marks, if I know that those angles are congruent, that allows me to, because they are, if you look at them, they are alternate interior angles, that allows me to prove that lines C and D are parallel. And then what we mean by using a converse theorem is because you would say A or C is parallel to D by the converse of alternate interior angles. Okay, C and D are parallel because of the converse of alternate interior angles. If I knew the lines were parallel and I was just trying to prove that C and D were congruent, I would use the alternate interior angles theorem. But since I'm actually moving the other direction, trying to prove I know the angles and I'm trying to prove the lines parallel, I'm going to go ahead and use the converse, because I'm headed in the other direction. Okay, so let's take a look at question number 4. Question number 4, we're going to be solving 3 problems from the book out of page 166. So let's take a look at those. This says, use the converse of corresponding angles postulate for the given information to show that P is parallel to Q. And so question number 1 tells us, and the drawing that the book uses is right here. We're trying to prove that P and Q are parallel. And it says that 4 and 5 are congruent. Okay, so if 4 and 5 are congruent, why does that prove that the lines are parallel? Well, what are they to each other? 4 and 5 are corresponding. They're both in that bottom left position. So we know corresponding angles are congruent. So that allows me to say, so just like I did on the last question, by the converse of corresponding, I can abbreviate, angles, P is parallel to Q. Okay, because the two angles there are corresponding angles, congruent course. So I would use, if they had been alternate interior, I'd say the converse of alternate interior angles prove that P and Q are parallel. Or if they had been same side exterior, I would say, and they said that they were supplementary, I would say then by the converse of same side exterior angles, P and Q are parallel. Okay, so we're using the converse when we know the angle relationships to prove that the lines actually must be parallel. Question 3 that I asked you to work through is similar. It's going to be the same drawing, but they're just going to make you do a little algebra to prove the two angles. So they say angle 4 is 4x plus 16, angle 5 is 3x plus 14, and then they tell us that x is 11. Well, so let's just work it out real quick. 4 times 11 plus 16, and 3 times 11 plus 14. And actually, let me just check. I think I wrote that down wrong. No, it is minus 19. Yeah, see, I did this. On number 3, angle 4 is, oh, I actually wrote the whole thing wrong. Good. Always make sure you're reading from the correct problem. Angle 4, according to number 3, is actually 6x minus 19. Okay, so let's fix that. Always worth checking. 6 times 11 minus 19. And if we work those out, we get 66 minus 19, which is 66 minus 19, which is 47. So that angle is 47 degrees. And the other one is 33 plus 14. And so that's also 47. So interestingly, all of that to see, okay, so the two angles, angles 4 and 5, are congruent. Well, let's go back and look up at our picture. Well, 4 and 5 are corresponding angles. So we actually, the same as number 1. They must be congruent. Again, did we learn that corresponding angles are congruent? Yes, they're not supplementary. So it's actually then, they're going to be the exact same thing I put on number 3, so that by the converse of corresponding angles, let's do that a little neater, P is parallel to Q. Okay, I could box both of these things, because you would expect that if the lines are parallel, 4 and 5 must be the same. Once I do the algebra on number 3, I can see that I do get the same angle measurement, so same reason. Let's look at number 5. Number 5, we're doing the same thing, except now we're trying to prove, I got to put the labels here, that line R is parallel to line S. And it tells me that 3 and 4 add up to 180. They're supplementary. Okay, does that make sense? Well, look at 3 and 4. What are they to each other? They're both interior of the two lines, and they're on the same side. So same side interior. Are same side interior angles supplementary? Yes, they are. So now, rather than saying converse of corresponding angles, here we would say by the converse of same side, oh, that looks bad, same side interior angles, R is parallel to S. Okay, because in this case, we've proved the lines parallel, not using corresponding angles, but using the fact that the same side interior angles, 3 and 4, are in fact supplementary. Okay. Oh, and that's the end of our lesson. So again, the bottom line is we learned all the angle relationships, the alternate interiors and exteriors, the corresponding, they are congruent. We learned that the same side, interior and exterior, they're supplementary. You only know that if the lines are parallel. This lesson is all about going in the converse direction, saying if you know those things, that they're supplementary or congruent, then you can prove that the lines are parallel. But it's really otherwise not anything new, other than saying if you're trying to prove lines parallel, that's when you would be saying you're using the converse property rather than just the straight up alternate interior angles or same side interior or whatever it happens to be. Alrighty, do your best on the quizzes and come in with lots of questions. We'll be practicing this tomorrow. All right, see you soon.